Hey there, Keith's Precalculus. This is section 2.3b. I am going over the remainder theorem and the factor theorem, and we're going to practice factoring a polynomial into all of its real number factors. We actually practiced using the remainder theorem in class, but I didn't call it that. Okay, I just told you to look at the bottom of page 117 to show what the remainder of a synthetic division problem will tell you. But we're going to go back and break it down more specifically in this video. The remainder theorem says if a polynomial f of x is divided by x minus k, the remainder is r, which is equivalent to f of k. Okay, so if it's x minus a number, then that number, if we evaluate the polynomial at that number, then we're going to get an answer, and that answer would also be the remainder of long division or synthetic division if I were to divide the f of x by x minus k. We are going to do this with an example. It says evaluate f of x, which is my quotient, at x equals -2. Now, x equals -2 would mean that my x minus k would be x plus 2. But I'm evaluating it at x -2 because remember, when I do synthetic division, I change my sign. If I'm given the factor, like this x minus k here, then when I do synthetic division, I change its sign. If you look up here, this says x minus k, but the remainder is f of k, whatever k happens to be. They're using the letter k. It's not the same as the k in the vertex form of the equation. This is just the letter that they chose to use in our book. I hope that does not confuse you. All right, so let's practice this so you can see what I'm talking about. So I rewrote my equation with a -2 in place of every x, so I can evaluate f of -2. We're doing this the way that we've done it before in the past, just to show you what the answer is, and then we're going to do a synthetic division and see that it's simpler. So 3 times -2 to the third is -8. So 3 times -8 plus 8 times -2 squared is +4, so 8 times 4, plus 5 times -2 gives me -10 minus 7. So 3 times -8 is -24 plus 32 minus 10 minus 7. So going in order here, that should -24 plus 32 gives me +8 minus 10 minus 7. So I get it. 8 minus 10 is -2 minus 7 equals -9. So we have found our old way that f of -2 equals -9. Now let's see if we can find that with synthetic division. With my synthetic division, I'm going to put my -2 outside my synthetic division box. I'm going to draw that, and I've got x to the third, x squared, x, and 7. I don't need a placeholder, so I'm going to put the coefficients 3, 8, 5, and -7, and I'm going to draw a line here because whatever is my remainder is going to be past that. Now I'm going to drop down my 3. -2 times 3 gives me -6. 8 minus 6 is 2. -2 times 2 is -4. 5 minus 4 is 1. -2 times 1 is -2. And -7 plus -2 is -9. See how much faster and simpler that is? And so if I evaluate f of x at -2, I get -9, and I can get that by doing synthetic division. My remainder is -9, so my r is f of whatever k is. So my remainder is f of, in this case, -2, which ends up being -9. See, my x would be x, or excuse me, my yellow, not my x, but my divisor would be x plus 2, because that is equivalent to saying x minus -2. That I'm just writing this extra over here so y'all can see that my signs are correct. Okay, that's the yellow. What I just wrote up here comes from the yellow divisor, x minus k. And this -2 is what we're putting right here. It's the opposite of +2. Okay, do y'all see how that works? Now I want you to try another one. It says, use the remainder theorem to evaluate f of x equals 4x squared minus 10x minus 21 when x equals 5. I would like for you to use synthetic division. I want you to pause the video and practice this. Put it in your notes. It's part of your grade for this assignment is to do this problem. And then once you've done it, or pause your video to do it, then once you've done it, come back and check your work with mine. If you need a hint to get started, you're evaluating at f of 5. I'm not changing any signs because I'm telling you that x equals 5. Okay? So go ahead and pause the video and use synthetic division to evaluate this polynomial. All right, I did the work. Let's see if you check your answer against mine. If you need to, pause the video if you need more time. Okay, but when you come back, you can see that my answer is 29. When I evaluate f of x at 5, when I plug a 5 into every x value and solve, I'm going to get 29. I'll do it if I do it the old way, but it's easier to do it if I do it with synthetic division. All I have to do is list my coefficients, multiply and add, and I get 29 as the remainder, and that remainder is f of 5. That's the remainder theorem. And the remainder theorem leads to the factor theorem. Because what if your remainder is 0? If your remainder is 0, that means your dividend is a factor, your divisor is a factor of your dividend, or x minus k is a factor of f of x if your remainder is 0. And that's what the factor theorem is telling you. See here, I wrote it out for you. The factor theorem says that a polynomial f of x has a factor x minus k if and only if f of k, when you evaluate the polynomial at k, equals 0. Your remainder is 0. If you divide something, a divisor, into a dividend, so if you divide something by a number or a polynomial, and you get a remainder of 0, that number or that polynomial is a factor of the dividend. Remember we did the example in class, or similar to this, 5 into 25. Well, 5 goes in there 5 times. 5 times 5 is 25. The remainder is 0. Therefore, 5 is a factor of 25. Same thing as 6 is a factor of 18. 6 goes into 18 3 times. 3 times 6 is 18. When I subtract, my remainder is 0. Therefore, 6 is a factor of 18, and so is 3. So 6 times 3 is 18. Those are the two factors. 5 times 5 equals 25. Those are two factors of 25. I did that with numbers instead of polynomials, but it works the same way. Only you would use polynomial long division or synthetic division to find, to see if f of k equals 0. Okay, let's do an example so you understand what we're talking about. I want you to show that x minus 2 and x plus 3 are factors of f of x equals 2x to the 4th plus 7x to the 3rd minus 4x squared minus 27 minus 18. And then after you do that, find any remaining real number factors. Now we're going to do this using synthetic division. That is the easiest way to do this, because x minus 2 is a binomial with a power of 1 and x plus 3 is a binomial with a power of 1. So what we're going to do first is we're going to evaluate f of x at x equals 2, because if x minus 2 is a factor, then 2 would be a 0. So I'm going to change the sign to 2 here. And I'm going to draw my synthetic division box. And I'm going to list my coefficients. Now, I don't have any missing exponents, so I can just write 2, 7, -4, -27, and -18. Make sure I have that right. 2, 7, -4, -27, and -18. Okay, I'm going to do synthetic division by dropping down my 2. 2 times 2 is 4. 4 plus 7 is 11. 2 times 11 is 22. Negative 4 plus 22 is 18. 2 times 18 is 36. Negative 27 plus 36 is 9. 2 times 9 is 18. And negative 18 plus 18 is 0. So yes, in fact, 2 is a 0 of that polynomial. Therefore, x minus 2 is a factor. So if x minus 2 is a factor, the other factor is what I multiply x minus 2 times to get my original. So I get the new factor by dropping down these 4 numbers as my new coefficients. And my power of my new polynomial is going to be 1 degree smaller than 4. So it's going to become 2x to the third plus 11x plus 18x plus 9. So my two factors so far are x minus 2 and then 2x to the third plus 11x plus 18x plus 9 because x minus 2 goes into the original polynomial evenly. It is a factor of it. Now I'm going to take these new coefficients right here and I'm going to create a new synthetic division problem with x plus 3. But I have to change my sign to negative 3 from this positive 3 because remember I have to change my sign because I'm doing synthetic division. And I'm going to put my new coefficients as 2, 11, 18, and 9. I do this, I could take negative 3 and put it into the 2, 7, negative 4, negative 27, and 18, and I would still get 0. But it won't narrow down my factor, and I'm not going to be able to find the rest of the factors if I don't do that. I need to, each time I factor this, I need to drop down a degree. And so I'm showing you how this works. All right, so I'm going to bring down my 2, and negative 3 times 2 becomes negative 6. 11 minus 6 is 5. Negative 3 times 5 is negative 15. 18 minus 15 is 3. Negative 3 times negative 3 is negative 9. And negative 9 plus 9 is 0. So now I've shown that x plus 3 is also a factor. So my factors now are x minus 2 times x plus 3 times, I'm going to get these new numbers because x plus 3 times, whoops, hold on. Sorry about that. 2x, now I'm going to go down one more power, so it's 2x squared plus 5x plus 3 equals my original polynomial. Okay, I factored it first to get my x minus 2 as a factor, show that x minus 2 is a factor. Then I used the coefficients of my new polynomial that came from the answers to my first synthetic division problem over here to create a new synthetic division problem, and I was showing you that x plus 3 is also a factor. By evaluating at negative 3, my remainder was 0, and so my next new factor would go down one more degree from the x to the third, and it would become 2x squared, and these are my new coefficients, 2, 5, and 3, so it would become 2x squared plus 5 plus 3. Now, if it said, after I do that, so I've shown that x minus 2 is a factor because when I do synthetic division, it's 0, and x plus 3 is a factor because when I do synthetic division again, it's also 0, but it said find any remaining real number factors. Now, 2x squared plus 5x plus 3 can be factored again. You can either do the quadratic formula, which is, I'm going to write it over here, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And my a, b, and c are going to come from this quadratic. Anytime I have a quadratic, I can solve it down into its factors by using the quadratic formula if it doesn't factor. So my A is 2, my B is 5, and my C is 3. Now, if I plug in a 5 here, 5 squared is 25, minus 4 times 2 times 3. So 4 times 2 is 8, times 3 is 24. Well, 25 minus 24 is 1. So I know that works. Okay, I can go ahead and just finish solving this. This was in answer to a question that a student asked today in class. Can I use the discriminant first to see if I have any real numbers? And yes, these are real number factors. So because because the discriminant is greater than 0, I know I'm going to have 2 real answers. So I'm going to go ahead and plug that in, and I'm going to get negative 5, because that's the opposite of b, plus or minus the square root of 5 squared is 25, minus 4 times 2 times 3, which gives me 24. 4 times 2 is 8, times 3 is 24, all over 2 times 2, which is 4. So when I simplify this, I'm going to get negative 5 plus or minus 1 over 4. And that's 2 different problems. That's the same thing as saying negative 5 plus 1 over 4 and negative 5 minus 1 over 4. Well, negative 5 plus 1 is negative 4 over 4, which gives me negative 1. And negative 5 minus 1 over 4 is equal to negative 6 over 4, which reduces to negative 3/2. So now I have my other 2 zeros, which give me my other 2 factors. So I'm going to come back over here on the left, and I'm going to write out all my factors. I know x minus 2 is a factor of the original polynomial, and x plus 3 is a factor because they gave those to us and we showed it. And now I'm going to write the factorization of 2x squared plus 5x plus 3, which is equivalent to x plus 1, because remember I changed the sign when I make it a factor, because it's going to be x minus k. Okay, and then x plus 3/2. Now you can be done, or you can change this 3/2 into something without a fraction. And I can do that as long as I multiply both terms in there by the same number. It still stays balanced. So x minus 2 times x plus 3 times x plus 1, and what will get rid of the fraction if I multiply both terms by 2? So that would be 2x plus 3. Okay, that's how I would finish factoring it, and I found now all 4 factors. This is my complete real factorization of the polynomial 2x to the 4th plus 7x to the 3rd minus 4x squared minus 27x minus 18. And that's how you can factor any polynomial of a higher power than 2. If you know that, if you can get it down to a power of 2, you can always just use factoring by grouping, or factoring by, or using the quadratic, you can use factoring by grouping, you can use completing the square, or you can use the quadratic formula to find the other zeros, which when you subtract them from x, they become factors. Side note, I'm going to redo this problem by factoring, by grouping. I'm taking this and I'm rewriting it up here. 2x squared plus 5x plus 3. If I did not want to use the quadratic formula or completing the square, I could factor by grouping if it's factorable, and it is. Okay, it's not, it doesn't give me a whole number when I do it by completing the square, but I'll get whole numbers if I do it by factoring by grouping. The only time I'm not going to be able to do that is to factor it is if I have irrational zeros, or irrational roots or zeros. Okay, so basically what I want to know is what I have to take the leading coefficient, which is 2, times the constant, which is 3. So I want to know what can I multiply to get 6, yet add to get 5. So what 2 numbers can I multiply together to get 6, but add to get 5? I can multiply 2 times 3, and that gives me 6, and 2 plus 3 gives me 5. So I can factor by grouping. This is just a review of what you learned in algebra. I can rewrite this as 2x squared, plus I'm going to take this 5x, and I'm going to rewrite it as a 2x plus 3x. Because isn't 5x the same as 2x plus 3x? It's the same thing. Plus 3. So I've just rewritten this. Now I'm going to group my terms. Okay? And I'm going to factor out what I can from this. I'm going to factor out a 2x from this first one, because they both have the common term of 2x, and I'm left with x plus 1. And then the second one, I can factor out a 3, and I'm left with x plus 1. So now you see that my two terms, 2x times x plus 1, plus 3 times x plus 1, also have the common factor of x plus 1. So I can regroup again, or I can factor out that again, and I'm left with x plus 1 times 2x plus 3. So this is the result that you got using the quadratic formula, only taking my fraction and turning it into whole numbers. Okay? So you can factor that quadratic any way you want. You can factor it if it's factorable. You can use the quadratic formula if it's not. You can complete the square if it's not. All right? I'm going to give you another one to practice by yourself. So you're going to copy the problem, pause the video, and then, or I should say, pause the video after I put the problem up here. Copy the problem and solve it, and then come back for the answer. Here's your problem. Use synthetic division to show that x plus 4 is a factor of f of x equals x to the third minus 28x minus 48, and then find the remaining factors and the subsequent zeros of the function f of x. Okay? Go ahead and pause your video and solve this problem, then come back and check your answers against mine. I will be checking your notes to see that you solved this problem. Okay, go ahead and study what I did. I changed the sign of 4, or x plus 4, so it became negative 4. I put my coefficients up there. I had to put a placeholder for x squared. I did synthetic division. I found that the remainder was 0. Therefore, f of x is equivalent to x minus 4, which is a divisor, times the quotient, x squared minus 4x minus 12. And then I could factor this into x minus 6, x plus 2. So the factors of f of x are x minus 4, x minus 6, and x plus 2. Therefore, the zeros are x equals, I'm going to go in ascending order, negative 2, that comes from the x plus 2, 4, that comes from the x minus 4, and 6, that comes from the x minus 6. So this set of x's are the numbers that x can be in order to make my f of x, the entire thing, equal to 0. Those are the zeros of the polynomial. I can also write them as negative 2, 0, 4, 0, and 6, 0. So these are all the zeros of the polynomial. So you have the tools to factor any polynomial. However, I may not give you a problem like this that says show that x plus 4 is a factor of that f of x. I might just say find all of the factors of f of x equals x to the third minus 28x minus 48. And where do you start when you come with when I give you something like that? That's what the next video is going to show you. I'm going to give you some more tools to help you narrow your choices instead of just guessing from nowhere. Of course, you could always start with a graph, but graphs are not always, well, they don't, if it's not a rational number, or if it's not a whole number, sometimes they're harder to read. So next video, we're going to learn some tools to help you narrow down your choices so that you can factor any higher degree polynomial.